Okay, now we'll be moving on to our next topic in this steel structure. So to start, structural members in steel structures are connected to other members by welding or bolting. So for example, we have a steel column here, and you're going to attach a uh, let's say a beam, for example. So how would you attach this beam to a column? Then that's gonna be by either welding or bolting. Of course, other joints, like for example splicing of beams. For example, this is the first length of beam, and you still have to, let's say, extend this length, for example, and you're planning to connect these two by either, could be by bolting or welding. So for example, let's just draw a bolting connection here, and also the base of the column, for example, in a portal frame, they are usually or somehow attached to a plate or connected to a plate. It's actually welded to a plate, and then this plate is bolted to a concrete concrete pedestal. Okay, so the point here is the design of the joints. It's either welding or bolting. The design of these joints is as important as the design of the members, because no matter how you design the members properly, but if you have a weak joint, then it will still lead to the the failure of the structure. Okay, so these connections, this welding and bolting, they are referred to as steel connections, and this is a characteristic, or let's say a difference between the steel structure um, and the reinforced concrete structures. I'm not saying that in reinforced concrete structures you're not designing the joints, because there are actually details on the embedments of steel bars and things like that. So it's actually um, in general the joints, it's actually important in any type of structures. But here, when I said there's this difference, I'm actually referring that there's like we we're using welding when dealing with steel structures, or we're using bolting. Now, some advantages and disadvantages of boltings. So now let's compare welding and bolts and bolting. Now, for bolting, the advantages, it requires um, less skill um, compared to welding. Now, of course, it's not that you're just hiring random workers here. Of course, um, except that in welding, you're actually hiring a um, skilled welder. So that's why bolting is much or uh, requires less skills as compared to the welding. Okay, so for the welding, you have to actually do the checking if the penetration of the welds is correct or not, and things like that. Okay, the second advantage. bolting produces no distortion of members. What I mean by this, if you're doing a weld, for example, this is our steel steel bar, and you're actually, um, let's say you are welding on this point. Okay, so this is our welding rod, and I'm trying to weld somewhere here. So when I'm doing the welding, I'm heating this portion, and you would notice that this point here, or this portion here, it's not actually heated up. I mean, it's far from this point, from this source or heat source. So therefore, there's going to be a temperature gradient between these these 2 points. So if that's the case, then there's it's going to produce a distortion, because when heating, then probably this point is trying to let's say expand or distort, while this one is not. So meaning that there's gonna be a distortion in the member, and that's why when you're doing the welding job, it's proper to provide braces to prevent this distortion. For for bolting, you just need to have holes, and you're not actually hitting the member, so that's why there's no distortion. Now the third advantage is it's rapid field erection. So meaning that you can actually do the the bolt holes. You can drill the bolt holes in a shop, and then you just have to install the bolts in the field. Now compared to welding, if you want um, a welded joint, then of course you have to, of course you do the alignments and then bracing, and then you have to do the welding and things like that. So compared to welding, the bolted joints will have a rapid field erection. And the fourth advantage is it is less extensive for inspection. As I've said, that when doing a welding job, you have to actually check the penetration. If Because welding, in welding, you're actually fusing this base metal together with the other metal. So you're heating that up until they fuse together. So if there's not enough penetration, then this joint will just be weak, and it will just break apart. Okay, so that's these are the advantages of bolt, the bolted connections. Now for the disadvantages, it has relatively limited in configurations. Okay, so when we say limited configurations, it means that, for example, how would you connect a pipe? For example, a pipe, and then say you're using a truss. I mean, you're using this pipe for a truss, for example, truss members, and how would you connect that? Um, you would um, you would have to provide some plates, or let's say a gusset plate, and then you still have to provide some parts to make a hole. So it's not as flexible as compared to the welding. So for welding, you can actually do a lot of configurations. Okay, so what if this member is somewhere here, right? So for bolted connections, you wouldn't have enough space. So meaning that you can't. I mean, you're not. I mean, bolting is not as flexible as the um, welding connection. Now, another one is alignments. Another disadvantages of this bolted connection is the alignment. Because you're actually um, providing holes, then you have to make sure that this hole is aligned with the, let's say this plate. Okay, this plate is plate. The hole in this plate should be aligned with the holes in the flanges of this, let's say, of this beam. So that's why it requires alignment as compare that to welding. The welding, it can actually accommodate a let's say a wider tolerance for misalignments. And the third disadvantage is it includes additional weights. Of course, the bolts the bolts itself, they have weights, so they can induce weights on these joints. Compare that to the welding. With the welds, it's just actually a small, something like a small part as compared to this one, to the bolted joints. Okay, so in our lecture handouts, I have also provided different steel connections, like for example here, the beam splices and beam to beam joints, the column bases, and many others. And also I'd like to point out that in these connections, either welds or bolted, like for example, we are trying to connect a beam to a column, then there are still other parts that's that comes into play. Like for example, the the flange seats over here. Okay, so it's like the equal leg angle, but it's actually providing a seat to this beam. Okay, so that could be bolted right here, and sometimes the end plates. Okay, so end plates, they're actually plates that where the, let's say, the I beam, this beam is welded, and they can provide holes for the connection, for the bolted connection, and many others. Okay, so just refer to our lecture handout for these parts. Now let's move on to the type of connections. So the type of connection, um, either welding or bolting, they can be classified as simple or eccentrically loaded. So meaning the simple connection is also referred to as the concentric loadings. Okay, so meaning that for example we have this bar and we have this line of bolts. Let's say this is our centroid. Now, if the loading of the force, or if the loading is along this centroid, then that's what we call a simple connection. But if, let's say, we have a loading that's not on the centroid, let's say it's, let's say this is the centroid and the loading is somewhere right here, then any eccentricity is actually inducing a moment. So let's say this is eccentricity, and this one would be referred to as eccentric loadings. Okay, so for us here, we will only consider simple connections, and another connection or type of connection for bolts is it could be, okay, so let's say this is number one, and this could be for bolts or welds. But the number two, this is only for, I think this is only for the bolts. We have slip resistant, and we can have bearing type connection. Okay, so let's write, this is A, this is B, this is A, and this is B. Okay, so for the bearing type connections, for example, we have these plates, and um, let's say we have a bolt over here. Okay, and of course we have a nut on this end. Now let's apply a load. Okay, so once you have applied the load, we have a bolt hole over here. Now take note that the bolt hole is larger compared to the bolt diameter itself. Okay, so let's assume for now that this bolt is concentric to the bolt hole. Now, once you actually pull this part apart, then you're actually this bolt is going to let's say to move or to produce a bearing on this something like this. Okay, so at first this is the bolt on the center, but after that, let's try the showing the top view. Then the bolt will actually um, make a bearing or a bearing action in this. Okay, so it's actually pushing this hole in this direction. So it's touching this. Okay, so meaning that in this type of connection, it's actually transferring the the forces from this member to this member. It's actually transferring the forces by bearing bearing on the bolt. Okay, and the bolts here, they're actually under the shear forces, and I think you have already encountered this type of loadings um, in mechanics of materials, where we evaluated the shearing planes. The other type of connection, the slip resistant, is actually a different thing, but let's draw the same configuration or the same setup. Okay, so we have these plates. Okay, so the first step in obtaining this slip resistant connection is to actually something like provide a pre-tension at the bolt. Okay, so you're actually pretensioning this bolt. Now, because you're actually pretensioning it, then, or in simple words, you're actually tightening it. So if you're tightening it, you're actually inducing forces here. Okay, so you have forces, and these members, they're actually transferring the forces by the friction here. Okay, so unless the external force overcome the the static friction, static friction in the surface, then that's the time that it will start to move, or it will start to something like displace or something, and probably it will become like a bearing type of connection. So this type of connection, um, again, this will make sense only if you're actually tightening the bolt, and you are designing the connection, this connection to transfer in shears, right? I'm not saying that the bearing connection is you're not tightening the bolt. Of course you are, and you should be tightening the bolt, except that the design intent is to transfer the forces by bearing here, and the bolt is in shear, whereas here the bolt is in tension. Okay, so I'd like to highlight this. It's because we will only consider this type of connection, the bearing type connections and simple connections. Now let's discuss the types of bolts. But before that, I'd like to draw first the bolt components. So let's say um, we have this bolt. Okay, and we have also parts like this, and we have parts like this. Okay, so this one is the bolt, the structural bolt, and this one is called the washer. In the course of machine design, you would actually learn that there are many types of washers. For example, the spring lock washers. But here we'll only have this, say, the plain washers. This one's the hex nut. Of course, it's called hex nut. It's just simply because you have a hex shape right here. So the same goes true with this bolt. If it's a hex, if the head is shaped like hex, then that's also referred as hex bolt, or hex head bolt, or sometimes H bolt. But for us here, the types of bolts in structures, we have three types of bolts. We have A307, we have A325, and A490. Okay, so the difference is that this A307 is actually referred as ordinary bolts. So that's for light structures. So example, purlins, gears, trusses, and secondary members. And these two, they're referred to as the high strength bolts. So meaning that they have higher strengths as compared to the A307. Okay, so um, oh, by the way, um, when dealing with structures, we notice that we have this these specified bolts A, so meaning that um, we are designated under the ASTM standards. Now there are still other types of bolts, and in machine design you would actually encounter various types and a lot of types of bolts out there, and also having different designations. But for us in the structural industry, then we are only considering these 3 volts. All right, now let's discuss the loads on bolts. Now the loads on bolts, that depends upon the connection. For example, if we have this something like a flange connection, for example, we have 2 members and they're connected in this manner by a bolt, and we are trying to pull this apart, or let's say the load is along this direction, then you would notice that if the load is on the bolt, they're actually it's in tension. Whereas if you have a say you have a connection, something like this, and you're applying the force, then you will the loads on the bolts, they're actually under shear. So this is shear, this is tension, and it's also possible to have a combined um, loadings. Like for example, we have say a cut plate, or let's say a connection wherein this is our bolt and this is our, let's say, our steel shape, or the W shape, or whatever. Now if this is the bolts, and let's say we have this something like in the truss member, then if there's a force right here, then what we'll see here is actually we can have a composition of forces. So we can either have in tension, and we can also have in shear. Okay, so this is shear and tension. Okay, so in the next video we will discuss the code provisions and derivations for this bolted connection.